Hello guys, in today's video I'm going to be discussing about one of the most important topics in laws of motion, which is writing free body diagrams. Now this video is going to be extremely dense and compact, and also this video is going to be useful for any type of competitive exams or board exams. So make sure to write the notes and pay attention. So without wasting any time, let's get started. So before we jump directly into writing free body diagrams, I want you guys to know about all the different type of forces which exist in the force chapter. Now the first type of force which exists is weight. Weight. You probably heard about this. Uh, Weight is just mass into acceleration due to gravity. Remember, there's a clear difference between mass and weight. Mass is just the amount of matter present in the body, whereas weight is weight W equal to mass into acceleration due to gravity. Mass is the amount of matter present in the body, whereas weight is mass into acceleration due to gravity. So the main description is description. Weight is just force due to gravity. Force due to gravity. Whereas the direction of this weight is always towards downwards. Towards downwards or towards the core of the planet. If the planet, sometimes they change the planet body in which the object is kept. In that case, you have to be knowing this particular thing, towards the core of the planet, towards the core. So diagrammatically, if you want to write, suppose you have a mass, suppose you have a block, and weight on this particular thing will be perpendicularly downwards, and this weight is equal to mass into acceleration due to gravity, or else you can simply call it as Fg, which is force due to gravity. Now this is the first type of force, and the next type of force is tension. So the second type of force we're going to discuss is tension due to strings. Now tension is just pulling force due to a string. So suppose you have a string and you have a mass attached to it. The the pulling force with this string exerts in order to keep this mass stationary is nothing but tension force. So tension is this force is over here, and then this is just the weight. So description wise, tension is just force due to a string, whereas direction wise, always away from the body. I'm trying to keep as much as simple as possible. So the description is force due to the string, whereas the direction is always away from the body. Remember, the tension in the string will always be directed away from the body. In this case, you can see it is directed away from the body. So make sure to remember that. And the next one is normal reaction. Now the description for this is force due to contact. Force due to contact between the surfaces. Suppose you have a book kept on the table. Suppose you have a book which is placed on the table. So this is the table, 3 dimensions. So this is the table. This is the book placed upon it. So this is the book placed on it. Now this book is supposed to fall if the only force acting on this book is gravity, which is weight. Now since the book is not falling, which means there is an opposing force which is acting on this book, which is keeping it stationary, and that particular force is nothing but normal reaction. So that force is normal reaction. So remember that the direction of normal reaction will always going to be perpendicular to the contact surface. So another way of visualizing normal reaction is just you can say, so I'll take an example. I have a book here. I'm holding this book. Now the only force we normally know which is acting on this book is gravity. The gravity is trying to pull this book downwards, but this book is not moving anywhere, which means there is an opposing force which is acting on this book, which is keeping it stationary, which is force due to my hand. Now this force is nothing but the normal reaction acting on the book. So same principles goes when you sit on the chair. So you exert force on the chair and chair exerts force on you. the force which chair exerts on you is nothing but normal traction. So I hope it is clear for you guys. So the next type of force which you have to know is, the third one is spring force. Force due to spring. It's quite easy. This force due to spring. Force due to spring. Now the direction varies. There are two different cases. One is compression, one is during compression, one is during elongation. So spring, as you know, you can compress a spring or elongate the spring. In these two different cases, there are two different forces acting on the spring. So let us see that things. So suppose you have spring, this is in rested state. Suppose this is the length of the spring. This is in rested state. No one is compressing or elongating this particular spring. Suppose I try to compress this spring. When I compress this, the length of this particular spring shortens. So it becomes somewhat like this. So suppose you're trying to push the spring and make it in a smaller way. The spring, due to its internal force, tries to push outwards. So during so this is the force due to spring during compression. So during compression, force due to spring will be outwards. So the direction of force in this particular case, which is force due to spring during compression, is outwards. Whereas if you elongate the spring tries to pull inwards. So suppose you elongate the spring, make the spring longer, the spring tries to pull itself inwards. The spring tries to pull itself inwards during elongation. So the force in this, but the direction of force in the case of elongation is inwards. So this was the fourth type of force, and the last one is friction. So the last one is friction force. So friction is nothing but a force which comes when two objects are relatively in movement with each other. So force when two bodies are relatively motion with each other. Suppose you have a block. And you make it to slide across a normal table. You make it slide and it goes to some distance and stops. Now what is making it to stop? What force is there on the table which is making it to stop? It is nothing but friction. So the direction of friction will be opposite to the direction of motion. So suppose the block is trying to go in this direction, the friction always try to oppose it. So the frictional force will be like this. So force due to friction is in this direction. So the motion, suppose it is in this direction, velocity is going in this direction, and the friction will be in this direction, and it will be over here because it's on the contact surface. The contact surface is the one which causes the friction. This is where the friction is going to be. So this is force due to friction. So direction is opposite to the direction of motion. So these were the 5 different forces which you need to be remembering in order to solve free body diagrams. Now let us see the rules involved in free body diagrams. So there are very simple rules which are involved in writing free body diagrams. There are only 2 rules which I'm going to tell you to you right now. Rules for writing FBD, free body diagram. So rules for writing free body diagram is, so the first rule is separate the body. So first select the body which you have to study, separate the body and write it diagrammatically separately. So the first thing is separate the body. Second rule is show all the forces acting on the body. Remember, on the body, it is important, not from the body. Not you should show all the forces acting on the body, not by the body. Remember, the first rule is separate the body which you are trying to study and then show all the forces acting on the body. It's extremely easy. So I'm going to do a few examples in order to show you how to write free body diagrams. So let us try with the first one. Suppose you have a block here of mass m. It's been tied to a ceiling of the roof. So we have to find FBD of mass m. So FBD of small m, block mass m. So first you have to separate the body. So I'll write it separately. Then identify all the forces acting on the body. So the first force which is acting on the body is due to gravity, as we all know, which is weight, is equal to m into g. And the next one is tension force. As you know, this is tied to a string, and the string produces tension force. and this is T, and this is mg. So the two forces acting on this particular body M is T and mg. So this is how you write free body diagrams. Let us go for a little bit complicated ones. So in this diagram, you have to draw FBD on free body diagram on the man. So there is a block attached to a pulley. So this pulley string goes around the pulley, and then there's a man who's trying to pull the block out of the ground. So you have to find FBD on the man. So first you have to separate the body, which is the man here. So separate the body and identify all the forces acting on the body. So the first force is due to his own weight, which is W, and the next one is normal reaction due to the ground, because C is standing on the ground is exerting normal reaction. So normal reaction due to the ground, which is N. Then the string force, which is tension T, which is acting on his hand, T. So all the forces, I'll merge them and write it at the center. So the FBD diagram of this particular man is, so this is N, this is T, and this is W, or singular dash, that is equal to M into G. So I write M dash because mass of the man, I already taken M here. So W equal to M dash into G. So this is the free body diagram of the man. So in this particular example, we have to find the free body diagram on the block A. So first thing, you have to isolate the body. So I'm going to isolate the body and write it over here. So this is how body A looks, and identify all the forces acting on the body. So the first force is Ma into G, which is mass of A into acceleration due to gravity, which is weight of A, Wa. And the next one is normal reaction of A due to its own mass, which is, I'll write N1. And the next one is normal reaction on this block of this block B on block A. So you have a contact surface over here. I told you, whenever you have a contact surface, you get a force called normal reaction. So there's a normal reaction over here also, which is, I'm going to write it as, I told you, the normal reaction is going to be perpendicular to the surface. So the normal reaction from the block B on block A is going to be perpendicular to this particular surface. So this is how it is going to be. I'm going to write it as N2. Make sure it is perpendicular. And then what you do in the final diagram, you just merge all those forces and write it at one particular middle point. So this is how it's going to be. So this is WA, and this is N1, and this is N2. So this is the FBD diagram of block A. Okay, for the next example, we have to find the FBD diagram of A. So there is a wedge and there is a ball here which is between the wedge. So I have to find the FBD diagram on block A. So first we have to isolate the body. I'm going to isolate and write it over here. So this is A, and then identify all the forces acting on the body. So one, obviously, due to its own weight, so WA. And the next one is, there is two contact surfaces, one over here and one more is over here. As you know, contact surfaces exert normal reaction in the perpendicular direction to the contact surface. So the one normal reaction is going to be like this. So I'm going to call it as N1, and the next one is going to be perpendicular to this particular surface, which is N2. It's not that perpendicular, so still it's okay. And then at the diagram, you just merge all the forces in the middle and write them down. So you have WA, and then you have N2, and then you have N1. So this is the FBD diagram of block A. So okay, now let us find the FBD diagram on mass M1. So first you have to isolate the body, sorry. So this is M1, and then identify all the forces acting on the body. So first one is obviously gravity, which is perpendicularly downwards. I'll write it as W1, and then the normal reaction to the by this block, which is perpendicularly like this, which is N1, and then from this particular block, which is N2, and then at the last, merge all the forces and write it down. So you have W1, you have N1, and you have N2. So okay, let's solve the last example. So you have a wedge which makes an angle of theta, say theta, and this makes an angle of theta, and there are three balls which are stacked upon each other. So all the balls are identical, which has same mass m, and we have to find the FBD diagram on the first block, this one. So the first thing is obvious: isolate the body M, and the next one, identify all the forces. So one is obvious, which is M1, or others write W1 equal to M into G. So the next one is normal reaction to this due to this surface, and normal reaction due to this particular surface. I'm going to write it down. which is perpendicular to the contact surface, which is N2, and this is going to be N1. So I put it in this diagram and write it as W1, N1, N2. So due to symmetry, you can see here all the balls are identical and all the forces should be equal. So this force is equal to this force, so N equal to N, and the next one is the angle between these two. So as you can see, if you connect the core of these three balls, so you have these three balls, if you connect the core of all of them, you're gonna get an equilateral triangle. So the angle of every angle of equilateral triangle is 60 degrees. So using that, I can find the angle between these two vectors. So you have an equilateral triangle in the middle. So this is 60, and obviously if you divide in the middle, this is going to be 30, and obviously this is vertically opposite angle. So this angle is going to be equal to this angle. So this angle is equal to 30, and similarly due to symmetry, you can get for this also as 30. So total angle is 60. So angle between these two is 60. So always remember, physics is just a little bit of theory and just 90% of maths. So that's the end of the video. I hope you liked this particular video. If you learned something new, make sure you subscribe to my YouTube channel, hit the notification bar, and I'm going to meet you in the next video. Thank you.